I'm Dusty Rittenbach. I teach physics at Rogue Community College. I'm also the chair of the Science and Engineering Transfer Department. And a few years back, I helped bring some 100 and 200 level engineering prefix courses to RCC. For many decades, we've had calculus and calculus-based physics and some of those other courses, but now we have more engineering stuff. And so I want to talk about some of the things that are important related to that if you're considering engineering. So we have a lot of courses. We'll look at a general overview of some of those that can help you go straight into your upper division. That is your junior and senior courses at the university. I'm going to talk about some common misconceptions about engineering that people might have. I'll do a general overview of specific transfer agreements in place, some of the details of scheduling for these intertwined courses, and being open to being flexible in what emphasis you choose, such as mechanical or chemical or electrical or whatever. And then because of all these 5 things here, make sure you contact advising early on. So for every bachelor's degree, in addition to your core classes for the major, you also have lumped together as general education requirements. And some of these you can pick and choose yourself. So you might be able to pick what literature class you have or what history class you have. There are specific speech classes assigned or required by the degree, writing classes, economics classes, so on and so forth. And if you wait till you transfer to take them, you are paying a significantly larger cost. We'll talk about some of how you price things, but at least 3 times as much. So because part of the cost of going to a university is also the living expenses. So if you have cheaper living conditions here when you're taking classes at community college than you would have when you transfer, that is part of the cost of going to university. Right. So there's a bunch of classes. How many you might want to take depends on kind of where you start here and how soon you want to transfer, but you could easily do more than 40 credits. All right. So I guess I would call it the core pre-engineering courses. Calculus 1, 2, 3, and 4. Calc 4 is also known as vector calculus, linear algebra, and differential equations. So that gives you about 30 credits. The 200 level chemistry sequence, Chem 221, 222, 223 is 15 credits. The 200 level physics sequence, pH 211, 212, 213 is another 15 credits. Our 100 level engineering classes are 2 credits each for 3 terms for a total of 6 credits. Some institutions have 2 terms of 3 credits. We've worked out a deal such that those transfer. And then the 200 level engineering courses, depending on what emphasis you're taking, you would either have more or fewer of those. So for example, an electrical engineer might only take engineering 201, which is DC circuits or direct current circuits like you'd have with a battery, and engineering 202, AC circuits, like you get coming out of the wall. There's more to it than that, of course. Well, a mechanical engineer would take those classes as well as statics, dynamics, strength of materials, so on and so forth. There are also some other classes that you might need to take. So, for example, before you can start the calculus sequence, you need to either test into calculus or take the Math 111 College Algebra, Math 112 Elementary Functions, which includes a lot of trigonometry. Degrees, particularly electrical engineering, also requires computer programming. Mechanical engineering requires welding. So there's, I guess miscellaneous covers it. So when you're thinking about these core classes here, don't forget about miscellaneous and the general ed requirements. All right. So one nice thing about RCC is that we have small classes. So you have more face-to-face time with your teacher. One of the disadvantages of that is that often we only offer a particular course once a year. So, for example, if you want to take engineering statics in the winter term, engineering 211, you have physics 211 as a prerequisite of that, physics with calculus, and you need to have either done calculus or be taking it, which means you've had to do Math 112, which means you did Math 111, so on and so forth. So if as part of the planning, someone says, oh, well, you should take the first term of physics in the fall, and it's like, oh, that didn't work out, I'll just wait till winter. You would need to wait for another year for that to come back. Now, that isn't always as terrible as that sounds. There's plenty of other classes you can take in the meantime. These courses, many of these courses have labs. Labs for a 3-hour lab. You pay 1 credit for it, and so you only get 1 credit for it. If that was not the case, no science, technology, engineering, math major could afford to get their degree. Some common misconceptions. First one is you have to love math. And it's been addressed in different ways, but do what you love is terrible career advice. So do what you love when you're 10, do what you love when you're 16, do what you love when you're 18. You need to try different fields of study, do some research on different fields of study, watch YouTube videos on different fields of study to know what's out there. And if you're only willing to work a job that you love every single minute of, you're unlikely to be employed. So if you're only going to do what you love, you aren't going to do much. The thing is, math gets more interesting as it goes up in difficulty, and that difficulty is kind of in air quotes, at least higher ranking math. My first day of calculus, the teacher walked in and said, welcome to your first interesting math class. And that's a little unfair to algebra and trigonometry, but there was a lot to it. So you can have a lot more going on. Another common misconception is you have to be smart for whatever you might mean by smart, and work ethic beats smart every time. Another misconception is, well, if you are smart and you love math, then you can just go through engineering and it'll just be a pleasant, easy time. Even if you do have those sorts of skills or temperaments coming into it, everyone has to work hard once they get there. And that's part of why some people tend to burn out. They think or drop out. It's like, oh, I'm not good at this. It takes me forever to do it. And the difference is there's between those people and the people who stay is, I'm not good at this. It takes me forever to do it. But if I work at it hard enough, I can make it happen. Engineers are sometimes seen as the stereotypical boring person, but they make things, and they make things that haven't been made before or made in that particular way. And humans are engaged by making things, particularly if they have to think about it and puzzle over it a little bit. If you think of popular video games, they aren't super trivial. Like a role-playing game, you start out at level 1 and you learn some skills and figure some stuff out, and then you can level up and tackle some larger challenges. And the reason why people pay money to do that for fun is humans like challenges. Those challenges should not be so challenging that they can never overcome them, but they shouldn't be easy. And you're going to spend a lot of your waking life at work. Choose something that is engaging. And again, that doesn't mean you're going to love every minute of it. But overall, when you look back on your life, you can say that you did something that was interesting. All right. So we have specific transfer agreements in place with Oregon Tech, Portland State University, and Oregon State University. Oregon Tech has been the best at formalizing our agreements into a degree. So we have Associate of Science Engineering Transfer Degree to Oregon Tech in Civil Engineering, Electrical Engineering, Mechanical Engineering, and Renewable Energy Engineering. And even if you're planning on going to another engineering university, signing up for this degree is probably the way you want to go if you have any financial aid considerations. So for the Associate of Arts Oregon Transfer Degree, AAOT, you only need 2 college-level math classes for that. So after you take Math 111 and Math 112, you financial aid doesn't want to pay for you to take any more math classes because you've met the threshold of math classes for that degree. So there's kind of sort of traditionally some ways around it, but you might not get financial aid to take calculus, and that's the lowest level math class that counts towards your engineering degree. Now, if you aren't at calculus, there's still lots of things you can do. The 200 level chemistry, for example, has a math co-requisite of Math 95. So while you were working your way towards calculus and the calculus-based physics, you can take your year of chemistry and that math and some writing and speech class. There's always stuff to do, but it's handy to have a degree with those classes that you need built into it, even if it's to someplace else. Oregon Tech has small class sizes, about the size of RCC, in some cases even a little bit smaller. So that's a much more manageable interaction with your teacher. It's a smoother transition from RCC to Oregon Tech to some of the bigger places. Klamath Falls is cheap to live in relative to some other places. And again, when you think about what it costs to go to a university, costs of living should be part of that. And there's no professional school to apply to. And I'll a little bit. So historically, there was pre-engineering, and that you would take at the university, and then you would apply to the College of Engineering. So just like you would apply to med school or law school, you had to apply to the School of Engineering. Oregon Tech does not have that. They have never had that, as far as I know. So you can show up there and take engineering classes without having to be accepted into that program ahead of time. Portland State worked well with us, get some formal course equivalencies. We haven't quite been able to get a degree with them yet. There's been a lot of turnover in administration here, administration there, so it's hard to get people back to the same, ramping people up. Portland, there's a lot of local business partners like Intel, Nikon, Tektronix, a bunch of big engineering, manufacturing, and design companies there. So it works well for internships. Portland is a bigger city than Corvallis or Klamath Falls, so there's a variety of housing options. They are unlikely to be as cheap as they would be in Klamath Falls. Portland State University courses, they're certainly larger than RCC or Oregon Tech, but they aren't super huge. And Oregon Tech now has a 5-year master's degree, so basically the 4 years of your undergraduate and then a 5th year for your master's degree instead of 2 years. So essentially what you do, instead of taking senior level classes or 400 level classes, you take the 500 level master's degree classes, be the first year of the master's degree. And instead of a capstone project, you just go ahead and start working on a master's thesis. Oregon State has the largest range of programs, so they're really big. And when I tell students that they're really big, some people don't appreciate how large really big is. So, for example, I pulled up one of the physics class enrollments for Oregon State, and for their calculus-based physics, they had multiple sections and a maximum enrollment of about 180 people. And it's going to be hard to get to know your professor with 180 people. And that's just part of the logistics. For curiosity, I looked at the first term of 200 level biology, and they have course limits of over 400 students per class. Again, you aren't going to get much face time with your professor for that. But being a big university, you have the big university experience, you have big football games, you have big clubs, you have bands that come and play that you might have actually heard of, things like that. They used to have a professional school that you had to apply to. That went away last summer. There are, of course, other options for engineering universities around the world besides the 3 listed here. And you're pretty good to go for taking your classes here and transferring wherever. So I certainly want to pay a little bit more attention to key aspects of that. But you're going to need all the calculus-based physics, so on and so forth. You're going to need the writing sequence. You're going to need the speech class. Whatever. And different engineering schools can have a different emphasis, so you might be able to pick something right away that's more closely tailored to your interest. Of course, if it's out of state, you're probably paying out of state tuition with the corresponding costs associated with that. All right, so I talked a little bit about this already, but to kind of come back to the same example, if you're doing engineering statics, that has a prerequisite of calculus-based physics, which has a prerequisite or co-requisite of calculus, which has a prerequisite of math 111 and 112, so on and so forth. And they're only offered about once a year because we have small classes. But even if you miss the boat there's lots and lots of other credits you can take. Oregon State is good these days about engaging with their community college partners. So usually in person, the community college engineering advisors meet about the week before fall term starts with the OSU engineering people. And one of their reports a couple years back was that 17% of engineering students changed their major within the first year, and about 32% change it before they graduate. So people look at electrical engineering and say, hey, that pays more than mechanical or civil, and might start out looking at electrical engineering. And there's a reason that electrical engineers get paid more. Electrical engineering is harder than civil. It's like humans have been making roads for many thousands of years. We've only been making microelectronics for a couple decades. So people change their mind, figure out they like something better. One thing that people don't consider often enough is a double major. So there's so many classes that overlap with a engineering degree that you can take just a few more classes and get another major, and not necessarily even another engineering major. So Oregon Tech's applied mathematics major. It might be an exaggeration to say 3 classes, but you probably only need to take another 4 or 5 classes on top of what you would take as an engineer to get that applied math degree. So why not? Oregon Tech's electrical engineering and renewable energy engineering particularly overlaps. I think there's only 2 or 3 classes different, so you can take it's easy to get a double major in that. All right. So because of all these nuances, contact me as soon as possible. The best way to get a hold of me is email. It's helpful for me to have actually your full name and your ID number, where you're planning on transferring to, what you're thinking of, what courses you're taking, what courses you have taken, and even if some of those are a bit vague. In the subject line, put engineering advising. That'll help me pick it out of my emails when people just have a blank subject line or just like, hey, or something like that. It can get kind of lost in the cruft. Right. So thanks for considering engineering at RCC, and I hope to communicate with you in the future.